Deep learning models consist of replaceable building blocks, like Lego bricks or like functions or classes in programming languages. I'm starting a series of videos about those building blocks, and the goal is to build muscles with deep learning so you can easily modify the existing models or build your own architectures. And the first building block that we're going to learn is a sigmoid. Why sigmoid? I think it's kind of cool. First of all, it's how the neural network started. They used sigmoid as activation function. Secondly, it's very well studied, so everyone knows logistic regression. And finally, it's still widely used. If it's classification model, there is very high chance there is at least one sigmoid in this neural network. Originally, sigmoid was invented to describe growth of the population because at that time they thought the population will grow exponentially, which obviously not the case. And Francois Verhulst, he realized that because of the limited resources like space or food, it will lead the population to plateau. And he found this perfect function, sigmoid. He called the function logistic function, and the name stuck. We still use it when it comes to logistic regression. And we can use this regression to predict a binary class, 0 or 1. Let's say we want to train a logistic regression model to predict whether a city in North America will have snow this winter based on latitude. Training a model, in this case, is finding a sigmoid that represents probabilities of snow for each city in the best possible way. Using the language of math, the best possible way is when the related loss function is minimal. For the logistic regression, the loss function is log loss, or binary cross entropy is the same function. In our case, we have two learned parameters, W and B. W scales the sigmoid horizontally, and B adds the initial offset. To better understand the theory, let's build a simple logistic regression in PyTorch. First, we define the model. In this example, in addition to PyTorch, we also use Lightning library. Lightning makes training just a little simpler, but in the future, we'll train the model using PyTorch alone. We create a linear layer that performs the operation Wx plus B and learns the parameters W and B. Then we apply sigmoid to the output of the linear layer. The sigmoid does not learn any parameters, it only transforms the output into a probability. In our example, there is only one parameter, it's latitude. If we want other parameters like latitude, longitude, and maybe the distance from the ocean, we can turn this into a vector, so we can combine multiple values, and learned parameters also become a matrix. In this example, multiplication of W and X turns into a dot product between two matrices, matrix W and matrix X. And the output of this dot product is just a value. And this value we feed to sigmoid, and that's how we turn multiple inputs into one singular output, just class 1 or 0. In our code, we just need to update linear layer input dimensions, and it will create a proper matrix. In the following code, we define the forward step. Calculate linear part of the regression and sigmoid. We also define a training step, which uses binary cross entropy loss. Once we train the model, we have linear weights, and it's all we need for the logistic regression. In this example, we passed inputs directly to the logistic regression. But sometimes we can have a really big model and we have logistic regression only on top of this model. It's like a cherry on top. So the inputs for this logistic regression comes from so-called latent space generated by the other part of the big neural network. And underlying part of the neural network can be anything. It can be a convolutional model, transformer, to tower, you name it. In other words, you can turn any model into a classifier just putting logistic regression on the very top of this model. That's why it's so powerful.